to discuss Lab2. Are you ready to look my screen and to make notes for yourself? Guys, don't sleep, please.
Don't go.
Sorry?
I am listening.
So, are you ready to listen and to watch screen?
Yes, sir. Don't.
Okay.
I am ready.
Okay. Так, do you see now my screen? Do you see my screen? Guys. Okay. So with this photo, converted from some photos in one, of rather big stand of hydraulic system located in 309 room K2 building. So we just will discuss it step by step. Значит, stop. I just will zoom it a little and wish to see these two pieces of stand. So here there is Ukrainian placards. Джерела тиску загальної системи. So power sources of combined system. Джерела тиску бустерної системи. So power sources of power control system. They are very similar, almost the same. You, I suppose, have read that power control hydraulic system have one more device which is absent in combined system. There are some modifications of wither plane, and this stand is from a little bit more modern modification. They remove from this power control system air turbine driven PEMP, RAM air turbine driven PEMP. And for me, it would be easier to remove it also, but almost all modern passenger plane has such air turbine-driven PEMF, which is why I leave initial version in my explanation. Stand I could not rebuild, I'm sorry. So let's look to these pictures, to this photo, and try to get idea of content of this hydraulic system and how they are organized. I suppose you can see in the scheme, page 9. So there are totally hydraulic system includes 3 subsystems, it's possible to say. Power control hydraulic system, which can be called boost hydraulic system, in Russian boosterная. Combined hydraulic system, which can be called main, in Russian what is основная, общая. And pressurization subsystem. Let's start from the most simple, pressurization subsystem. The pressurization subsystem is independent, but it has 2 common devices. There is with fitting its ground connection for high pressure air to provide ground operations of hydraulic system, actually ground tests. And in parallel, there is a connection air bleed port from engine. So you remember that there are some kind of consumers on board the aircraft for high pressure air which we take from engine. One of these consumers is pressurization system of hydraulic tanks. So by the principle of operation, it's very similar to fuel system, but has usually higher overpressure. These sources are interconnected, and of course here there is a check valve, here there is a check valve to prevent air release via inoperative engine and ground or via with connection in flight. Next, always air is supplied to air filter. This device it's air filter. So air supplied to hydraulic system from outboard must be filtered beforehand to prevent mechanical impurities getting to hydraulic system. Так, let me a little bit. And next, behind the filter, there is a T connection. from which two branches goes to left and right. One goes to pressurization bottle of the combined hydraulic system and another to power control hydraulic system. What you can see here, actually, from the left side, you see picture. From the right side, it's actual device, actual bottle. Unfortunately, we could not access the room and see it in detail, but we will discuss this component next time at second level. So, in the connection to the pressurization source here, in the bottle, there are two devices built in. There is a rough filter and check valve. So, each bottle in the inlet has check valve. What for? Try to think a little. In case of this pipeline will be destroyed, this check valves will prevent immediate air release back to atmosphere, and the bottles will keep some pressure, high pressure air to provide pressurization during some time. It's of course not for some hours, it's for some minutes, but maybe with minutes will allow to the pilot to tune to level flight, to direct airplane back, maybe to eject safely. So with minutes may be very important. From other side, the bottle has outlet and connected to pressure regulator. With actual structure, this is picture of pressure regulator. Pressure regulator should reduce air pressure from this bottle to suitable for hydraulic tank. So of course the bottle contain higher overpressure than in the hydraulic tank, so to provide pressurization during some time. It's like a source of high pressure air. Next, there is pressure release valve, actual structure with a manual handle and picture. Pressure release valve is intended to release extra overpressure to atmosphere during climbing aircraft to the bigger altitude. Pay attention that we must provide definite overpressure in relation to ambient atmosphere. And this overpressure should not exceed limits, otherwise hydraulic tank will be overloaded and can be destroyed by this overpressure. So when airplane climbs to high altitude, ambient pressure drops, so overpressure from the tank must be released. This is primary function of this pressure relief valve. And also it can be used manually by this handle, so ground maintenance personnel can press this handle on the ground. If you need to detach some pipelines of hydraulic system, first of all you need to remove overpressure from the system. And one of the action which you should do to release overpressure from the hydraulic tank. Next, from which side of this pressure relief valve pipe, black, you see hydraulic overpressure line are of black color, so air inside, and this black line comes to the hydraulic tank. This is hydraulic tank of combined hydraulic system, and this is of power control hydraulic system. So here another pipeline goes to hydraulic tank. Hydraulic tank structure we will discuss next time. Now let's say about its connection. Hydraulic tank, let's say zoom a little, has on the bottom some devices with connections. One connection you see with line, and it comes to fitting. This is suction fitting for external ground pump. So for creation of overpressure in the hydraulic system and for testing of hydraulic system on ground, to save service life of engine, it's possible to use external ground pump. It's not the best solution. In modern wood, such solution almost not used, but in that time when this airplane was created, it was assumed lighter. The structure became lighter. So there are no electric motor-driven pump on board. In modern wood, almost everywhere there are electric motor-driven pumps which don't require this connection and allow to provide ground tests without ground pump. So, and another connection, this is supplied to main pump, with. This is NP96A, so it's насос плунжерный 96A, plunger pump 96. So 96 designation, plunger pump, we will discuss it next time in component hydraulic in lab book. And the same from other side. There is suction connection for ground pump, and there is suction connection for hydraulic pump. Sorry, from this side, for hydraulic pump. Hydraulic pump, here there is only picture, because if you will look to side view, you will see nothing. From the hydraulic tank, there is outlet to the pressure line. And here you see T connection. With T connection going from another fitting. Ground pump has suction connection and pressure connection. These connections are especially done of various sizes. So suction lines are made of aluminum alloy, pressure lines are made of stainless steel. They can withstand quite different overpressure. And in case of accidental run attachment, vice versa, you will destroy aluminum pipelines by high pressure. So to avoid wrong connection of ground facilities, these fittings are made of different size. You can also see them here. You see here big diameter, here low diameter. It's a little bit more difficult for designers, but it guarantees that this problem can be avoided in operation. So this is from onboard PEMP, this is from ground PEMP. According to the picture which you have in your lab work manual, in parallel to this engine-driven PEMPs, with engine-driven PEMPs, power control hydraulic system has one more air turbine-driven PEMP, which is absent in this modification, and which also is attached in parallel, so to the T connection will be connected outlet of the PEMP. Next, from all these power sources, engine-driven PEMP, air turbine-driven PEMP, ground PEMP, all the pressure lines are united in T connections and are supplied to the pressure filter. This is pressure filter structure. This is pressure filter schematic. So T connection and inlet to the pressure filter. Next, from the pressure filter, hydraulic fluid comes to automatic bypass valve. Automatic bypass valve we consider at lecture. I will not discuss it in detail now. This structure is a little bit more complicated than you have in the lecture. Picture which is in the page 9, it's just one-to-one as in the lecture, and you recognize this device, I think, easier. Next, so here there is a picture of automatic bypass valve. Here there is actual structure. It's rather complicated device. And so you see this connection here. And this is outlet. Outlet coming to hydraulic accumulator. Hydraulic accumulator. This is actual structure, spherical or ball type hydraulic accumulator or diaphragm type. And this is picture. So this picture you have in synopsis, one-to-one, like in synopsis, the same structure is used. And behind hydraulic accumulator, you have two outlets. One line is going directly to primary sources. One line is going to primary sources. This line, I think. And another line is going to priority valve. These are priority valves. This is real structure, this is picture. Priority valve is used to separate criticality devices and low criticality devices. What does it mean? I suppose you have read it in the book. I repeat in other words. So any airplane, any helicopter has the most critical devices without which you will lose control immediately and it will be immediate crash. In this airplane, it is spoilers control and stabilizer control, which provide pitch control and roll control. As for other devices, they are assumed a lower priority or secondary consumers, and so they are supplied with hydraulic fluid via priority valve. What does it mean? In case overpressure in hydraulic system is as it should be, 21 megapascal plus minus, it's all consumers are supplied with hydraulic fluid. But when hydraulic overpressure drops below 15 megapascal, priority valve will cut the secondary order consumers off to keep high pressure fluid only for primary consumers. So to provide stability, controllability of the airplane. As for other devices, they will not work in these conditions. So each hydraulic system has first priority and second priority consumers. And so will be two lines. One line is going from here to here with this priority, high priority, and another line is going with, it is secondary consumers. It is for main system, and here will be with line. It is for high priority valves of power control hydraulic system, and this line, it will be for lower priority power control hydraulic system. Let's now consider power control hydraulic system consumers. No, first of all, high priority with line. It goes to the right and to the left. First of all, you see here a set of devices which are placed near to each other. Two here you see, and three here. These are self-locking valves. So they are located in attachment cross-section of front fuselage section and rear fuselage section. This airplane has fuselage attached from two sections, front and rear. And it was done to provide engine replacement. I suppose you remember our first semester lab works, Mikoyan 15, Mikoyan 19, Mikoyan 21, Yakovlev 38, have similar idea. Tail part of fuselage is detached, so to remove engine, to install new one, and next attached back. So in this cross-section, hydraulic lines should be detached and should be quickly detached and without leakages. And next should be quickly attached, also without mechanical impurities and air locks inside. So with self-locking valves, just with devices which provide quick disconnection and quick reconnection. So we are passing by this line, top line. And from this top line, pipe goes down, 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 and comes to stabilizer control actuator. So you see here Ukrainian placard, управління бустерами стабілізатора. So it's control of stabilizer actuators. The airplane has two stabilizers, right and left, and it provides differential control. In such class airplanes, the stabilizers usually used not only for pitch control, but also for differential control, so for roll control. So each stabilizer can provide function of ailerons and functions of elevator. So as you see, stabilizer is, here there is a picture, but it's easy to see. It has two chambers, one and two chambers. So it's tandem type actuator. And it is attached to two hydraulic systems. You now see connection of power control hydraulic system, but the other chamber is connected to combined hydraulic system. So as a result, we can say that in case of any one hydraulic system failure, this actuator will continue to work. So it's so-called hot redundancy or duplication, and provide ultimate reliability, but of course a greater weight. So this is one of the concerns. Let's turn back and by this stop line go to the left. To the left, and near to the left you see here also line going down and approaching to similar device. This device is, as you see, boostera interceptor. So it's spoilers actuators. So each wing will include similar but a little bit lower size tandem type actuator, which is used to control spoilers. In this case, spoilers, it's spoilers which are intended for roll control. It's not only ground spoilers. So they are feedback like a stabilizer and provide differential control, of course, for roll to the left or to the right. And also, sorry, also we should consider a low priority line of this system. This is thick line, which approaches to this device. This device you see here, SPK1, wing motion system. So airplane, which we consider Mikoyan 23, has a variable geometry wing or wing which changes feedback angle, and this structure allows you to do it. So here there are pair of hydraulic motors. Each hydraulic motor is attached to own hydraulic system, one to power control, another to combined. Next, they are attached to reduction gearbox, so they attach via differential mechanism. So in case of any one hydraulic system failure, another will work and provide all the function, but with twice low speed. And next, with differential gearbox, tunes rotation to screw and nut actuators, which with a screw and nut actuator, one side is fixed to fuselage, but another side will be fixed to the eye or fork on the movable wing. It's just a wing which you can see in 208 room left remote cone, and just with eye was controlled by this screw and nut actuator. That's almost all for power control hydraulic system. So it has a few of consumers. Let's turn to combined hydraulic system. Combined hydraulic system have also high priority consumers, which are attached here with line, and this line goes to the tail part, goes here, and attaches to the secondary chamber of the same actuator of stabilizers. If we return back, we will come to T connection, and you will see here these devices. What's sorry, it's another, so here nothing. Let's turn back. High priority consumers will be also here. Here we approaching to another chamber of spoilers actuator, and that's almost all. And as for secondary consumers, which are attached via priority valve with bottom line. With bottom line have a lot of consumers. They go to the tail part and approach to this block. So this is electrohydraulic valve, which allows to control speed brakes. Here you see four actuators, two in the top are of low size, two in the bottom are of big size. So these are also feedback devices, which allows to deflect outwards speed brakes or air brakes and allow to decelerate airplane in flight when you need to drop the flight speed. So for maneuverable airplanes, it's very important device. Let's turn now to the opposite side and you will see something else. Pipeline is going to also to wind motion system and is going to these devices. What we have here? We have nose wheel steering system. Here it is shown as one unit, and we will not discuss it in detail, but nose wheel steering system, you will see the abbreviation in the picture, NWS, nose wheel steering system. And in the bottom, you see this device. It's control of air intake. It's also one unit here shown. In your book, it will be extreme left cone in the bottom, so air intake control, and one hydraulic cylinder actuator for air intakes. Feature of this airplane, it has two air intakes arranged side by side to the fuselage, and it allows to use one actuator and a mechanism, rather simple mechanisms, rods and bell cranks, and it's enough to control both air intakes. So a feature of its arrangement. Next, here there are also slots control. Sorry, not slots, in this case, leading edge flaps. Leading edge flaps. Also, this airplane has as minimum three various modifications with high lift devices. And here you see maybe the last modification, the most modern, as opposite to 208 room where there are slots. Here, leading edge flaps. Leading edge flaps here are controlled independently from flaps by hydraulic actuator, one per each wing. So this is real structure, which is this picture. One actuator placed in one wing. There are four sections of slots, but they are controlled by a single actuator. And here you see a pair of electrohydraulic wells, one and another. Some sequence wells you see here, and flaps actuators. Here there are six. One pair, second pair, and third pair. Each wing has three flaps: inboard, midboard, and outboard. So by pairs, with pair for inboard, with pair for midboard, and this pair for outboard. All the flaps are interconnected mechanically, but each of them has own actuator, and this interconnection link can be destroyed by damage, some damage, and can be controlled independently. These flaps actuator are interesting devices which allow to fix flaps in three different positions. So you see now picture, and here there is a connection to the aircraft, to the wing. This is connection to the flap, and this green piston is of low diameter attached to the flap. This is floating piston. It has bigger diameter. Here you see step in diameters. And so it provides in rather simple manner free position of the high lift devices. When you need to extend flaps, you supply high pressure fluid and it is permanently supplied to the right connection here, and both other connections are attached to return line. As a result, all the pistons are retracted, and retracted state of these pistons correspond to extension of the flaps, a 50 degrees extension, maximum deviation angle. It's a landing position. When you need to extend the flaps in the takeoff position, 25 degrees, half of this motion, you supply pressure to both extreme lines, here and here. In this situation, and middle you also attach to return line. In this situation, fluid which comes from the left presses floating piston to the right, and floating piston comes to this stopper. because change in diameter doesn't allow the floating piston to go to the right further than this point. As a result, floating piston, which has bigger area, forces piston attached to the flap to the right, but not to extreme position, but to intermediate position. And so the flaps will be in the intermediate position, take off 25 degrees. When you need to retract the flaps, you connect left cavity to return connection, but middle cavity to pressure line. As a result, pressure fluid comes here, moves floating piston to the left, moves with rod and the piston to the extreme right position. So extended position of this rod correspond to a retracted position of the flap. So it's general idea for all the flaps. They have different size, but the same principle of operation. It's possible to mention essence of these sequence wells. Their idea is to prevent damage of flaps when wing is retracted and some portion of the flaps entered inside slots and fuselage, and it prevents fuselage damage if pilot accidentally tries to extend flaps when wing is retracted. So it's mechanical sequence well which prevent accidental wrong motion. And the most complicated subsystem which is left, it's landing gear control. It is this device. Here the most important device is this. It's electrohydraulical valve, gas-142. We will also discuss it at next lab work in detail. So it's control device which controls all both main landing gear legs and their jaws, nose landing gear leg, ventral fin retraction, and turbine starter doors. So this device is connected to a high pressure line in the top of combined hydraulic system and also attached to return line. Outlets, here there are two lines, one for extension, one for retraction. Now we will see what for each line is intended. So the valve can connect pressure line here, return here, or vice versa, or can connect both to return. Normal state, de-energized when both lines, internal lines, are attached to return line and pressure line is blocked. Let's imagine that we supply high pressure to the left line and right is still connected to return line. What it will be? Pressure comes here, comes to this hydraulic turbine starter doors for the opening, comes to this it is disconnected, the tail part of the fuselage comes to this hydraulical actuator of mechanical lock. Pressure comes here, extends the piston mechanically pushes and opens mechanical lock, and only after this fluid can get to this cavity, and via this cavity is supplied to this hydraulic actuator. It's hydraulic actuator to retract ventral fin. And from opposite line, it of course goes to return line. Next, from this line, it comes to this T connection and goes to this pair of mechanical locks actuators. This is picture, this is real device. This goes to the left landing gear leg, this goes to the right landing gear leg, and this line goes to nose leg. The devices are absolutely identical. When pressure is supplied to this cavity, it pushes this piston to the left. Piston extends and its rod will open mechanical uplock. So landing gear legs will be released from the mechanical uplocks. After that, pressure can go to this outlet. From this outlet, it comes here. This is hydraulic lock. The same you can see here, but it is metal structure. And similar lock will be here also with its metal, but it is picture. when pressure comes to this device, it opens hydraulic lock and passes here and comes to extension cavity of the actuator. It extends with hydraulic rod, so it allows to extend main landing gear leg. In the same time, pressure is coming to these devices. These devices are hydraulical cylinders to open a bottom jaws of the landing gear legs. But actually, these bottom jaws can be opened mechanically by landing gear legs. Landing gear legs are powerful and heavy enough to extend these doors. Here there are sequence wells which are very important during retraction. During extension, they are not so critical. First of all, we must open the doors and next extend landing gear, but during extension, it's not a problem. So the same operation take place with a nose leg. And in addition, here there is one more device with cylinder of automatic braking. So this device sends mechanical signal to the pneumatic wheel brake system, which allows to brake wheels before retraction. But it also activated before extension. No, it's not critical, but it works as this. So, landing gear extension cycle is you open electrohydraulical valve with, it supplies high pressure fluid to the left line. From the left line, fluid comes to the actuators of mechanical locks, opens mechanical locks, and after that, only after that, it comes to hydraulical locks, opens hydraulic locks, and comes to extension cavities, extend landing gear leg, and in parallel comes to the cylinders and opens bottom doors. In the same time, fluid comes to starter gas turbine starter jaws and extend air intake and exhaust nozzle for the turbine starter, and comes to mechanical lock and next to actuator of ventral fin retracts ventral fin, which allows to make a landing and without damage of the fin. Okay, after that, with hydraulic valve will be de-energized. And in this state, hydraulic lock will block extension cavity so that even in case mechanical lock, which is built in here, we will discuss it next time, will fail, hydraulic lock prevents landing gear retraction in case of landing and loading application to the landing gear. Similar structure in the nose leg, but mechanical lock is a little bit different. For retraction, we activate energize opposite solenoid and we supply high pressure fluid to opposite line. And it works almost vice versa, but not exactly vice versa. First of all, this hydraulic fluid comes to, so here something attached wrong, and I will say not as in the picture, but as it should be. It should come to this T connection. And from this T connection, it comes to sequence valve, and only after landing gear retraction, it will pass fluid for the DOS actuators to close the door, so we must not close the door before landing gear retracted. It comes to retraction cavity, this cavity of landing gear actuators, opens mechanical locks which are inside actuators, and begin to retract landing gear. When landing gear will be retracted, after that, they will mechanically press to sequence valve, and only after this they allow sequence valve to pass the fluid to these actuators and to retract jaws, the closed jaws of landing gear legs. In the same time, in parallel with automatic brake cylinder will give mechanical signal to the pneumatic system, braking system. In the same time, nose landing gear leg will be retracted, Actuators for locks are not used now because mechanical up locks will work automatically. When landing gear approaches to the up position, it will be locked automatically. And finally, in the bottom, you will see that gas turbine starters doors will be closed. Opposite connection with connection should be used for gas turbine shutter doors. And ventral fin extension cavity will extend and extend ventral fin so it comes in the flight position. I see that our time is over, so I terminate screen sharing. And I'd like to say some extra words for you. I suppose you get some ideas about hydraulic system, but I understand that of course it's difficult via the remote action. That I'd like to stress the following. I just put in the mentor questions is for both models. Please look in the top of our course. It will be a reference questions for models 1, 2. Look for them, and I think you can now pass first model, because all the lectures you're given, it's team 1, 2, 3. Actually, 2 and 3. Second model will include teams 6 and 8. So teams 4 and 5 will not be checked in the model because some changes in our time and in the doesn't allow me to change always. So our time is over for today. That's all. If you have any questions, you can ask.
Sir, this is Maduki. I just wanted to know if there is a time limit for the model.
Oh, yes, of course, there is time limit. Look, you will
Oh, okay, sir.
see.
Okay, sir. Okay, sir.
There is, of course, time limit. No, it's also about 20 questions or 15 questions. I think here 15 questions.
Okay, sir.
Don't force I don't force you to pass model today. You can do it all time within the semester.
Okay, sir. No problem, sir.
So
Thank you.
or if no other questions, that's all for today. Thank you for attention and goodbye.
Yeah. Goodbye, sir.
Goodbye, sir.
Okay. See you next week.
See you, sir. Thank you, sir.